horizontal and is formed mainly by the right ventricle and partly by the left ventricle nearly the apex. The left border of the heart is formed mainly by the left ventricle and to a slight extent by the left auricle at the superior end. And the upper border is composed mainly by the right and left atria and its auricles. So these are the clinical and the anatomic location of valve areas. So the clinical, the original location of the valve areas, and the heart sounds is transmitted in these areas. For the pulmonary valve, it can be best heard at the left second intercostal space, and the aortic valve at the right intercostal space and the second intercostal space, and the mitral valve at the fifth left intercostal space, and lastly the tricuspid valve at the left lower part of the sternum. So for the mnemonics, you can remember, please answer my telephone. So for the exam, okay, it will come out in the exam. Please answer my telephone. It will usually come out during the board exams. So the heart is obliquely situated in the thorax, in between the lungs, and it lies approximately 1/3 from the mid-sternal line to the right, and 2/3 from the mid-sternal line to the left. So the heart is covered by a pericardium. So it's a fibrous membrane. It's a closed sac which is composed of 2 layers. So the green lining of the heart is the fibrous pericardium. It completely surrounds the heart, but it's not attached to it. The second layer, the purple one, is the serous pericardium. So the inner lining is the visceral pericardium, which forms the outer lining of the heart, and it forms the epicardium, which is as I said, the outer lining of the cardiac wall. So the next layer is the outer layer, the one that lines the inner surface of the fibrous pericardium is the parietal layer. In between these 2 layers is the pericardial cavity, in which is a potential space that normally contains a thin film of fluid that allows the heart to move and beat in a frictionless environment. So this is the actual picture of the pericardium, in which it is continuous to the tunica adventitia of the great vessel superiorly. Not seen in this picture, it is attached to the posterior surface of the sternum by the sternum pericardial ligaments, and posteriorly it is bounded with the loose connective tissue, the structures of the posterior mediastinum. Inferiorly, it is continuous with the central tendon of the diaphragm. Pointed in this slide is the parietal layer of the serous pericardium lining the inner surface of the fibrous pericardium. So the pericardial cavity, the pericardium may also be involved in different disease processes, and one of these is the pericarditis. So pericarditis is the inflammation of the pericardium in which it causes pericardial effusion. So meaning there's a lot of fluid that accumulates in the pericardial cavity. So the red one. So what happens to this is that the heart will be compressed and it unable to expand fully or fill fully, leading to circulatory failure. So why is this so? It's because the fibrous pericardium is not elastic. It does not allow full expansion of the heart, and it limits the amount of blood the heart can receive, causing decrease in cardiac output. As a result, the veins of the face and the neck becomes engorged, and because of the backup of blood, so this patient has cardiac tamponade. So if you're confronted with this kind of patient, what will be your emergent treatment for this patient? We can do pericardiocentesis. It's a procedure done to remove the fluid from the pericardial cavity to relieve the patient from the tamponade and to relieve the patient from the symptoms also. So the next is the transverse pericardial sinus. So it's a transversely running passage within the pericardial cavity in which it is bounded anteriorly by the ascending aorta and the pulmonary trunk, posteriorly by the superior vena cava, and inferiorly by the atrium. So this is clinically important, especially to cardiac surgeons. Why? Because we can insert finger in this area to ligate the vessel or to put a clamp in this area to stop or divert the blood flow while doing surgery, cardiac surgery, to minimize the bleeding. So this is the interior of the pericardial sac. When the heart is removed, the 8 vessels piercing the sac were severed also. So we can see here clearly the transverse pericardium and the oblique sinus, so which is circumscribed by the five veins. During cardiac surgery, we can insert our hand in here in this area because it's the free area of the heart. So the heart, the adult heart, measures 12 centimeters in length from the base to apex. And it is the atria, they are demarcated from the ventricle by the coronary sulcus, and the ventricle, they are demarcated from each other by the interventricular groove, or the sulci. So the posterior aspect of the heart, or the true cardiac veins, this one. This is composed mainly of the left atrium and the posterior part of the right atrium. In recumbent position, it is at the level of T5 to T8. However, by gravity in erect posture, it is at the level of T6 to T9. So there are 4 surfaces of the heart, and one of these is the anterior surface, or the sternocostal surface, which is formed mainly by the right ventricle of the heart, and the inferior or diaphragmatic surface, which is formed mainly by the left ventricle and partly by the right ventricle. Then the right pulmonary surface is formed mainly by the right atrium, whereas the left pulmonary surface is formed mainly by the left ventricle and to a slight extent by the left auricle. So it also forms the cardiac impression of the left lung. So I've mentioned this already, the cardiac borders of the heart. The upper border is formed by the right and left atrium and its auricles, the right border by the right atrium, the inferior border by the right ventricle and partly by the left ventricle at near its apex, and the left border is by the left ventricle and partly by the left auricle at its superior end. So one of the important external feature of the right atrium is the presence of sulcus terminalis. So this demarcates the true atrial from the venous component of the right atrium. So the sulcus terminalis, internally, it corresponds to the crista terminalis, which is the site of origin of the pectinate muscles. The posterior part of the right atrium is thin-walled and it's smooth. We call it a sinus venerum because the superior vena cava, the inferior vena cava, and the coronary sinus empty in this area. So the septal wall of the right atrium, there's a oval expression called fossa ovalis, which is the remnant of the fossa ovale. The right atrium also has an opening, as an ostrum called the coronary sinus, in which it receives most of the cardiac veins of the heart. It is located in between the AV and the inferior vena cava orifice. So in cut section of the, am I too fast or too fast? Okay. Cut section of the right ventricle, there is an irregular muscular elevations known as trabeculae carneae, and the right ventricle also has 3 papillary muscles. One is attached to the anterior ventricular wall, the other to the posterior ventricular wall, and to the septal wall. Arising from the papillary muscle are elongated collagenous structures known as chordae tendineae, which support the cusp of the tricuspid valve. The tricuspid valve has 3 leaflets, the anterior, the posterior, and the septal wall, and this guards the AV orifice. So in this area is the supraventricular crest, which demarcates the right ventricle, the muscular ventricular chamber from the smooth walls of the conus arteriosus. And this is the pulmonary valve. Found only in the right ventricle is the presence of septomarginal trabeculation, or the moderator band. So this traverses from the inferior part of the interventricular septum to the base of the anterior papillary muscle. So it's important because it carries a branch of the right branch of the AV bundle towards the anterior papillary muscle to facilitate conduction time. So this is only found in the right ventricle, and it's not found in the left ventricle. The left atrium as compared to the right atrium. It has a larger posterior wall where the pulmonary veins drain. The left auricle is smaller as compared to the right, and it contains the pectinate muscles. The left auricle also is narrower, longer, and it's more hooked as compared to the right. And also, it has slightly thicker walls as compared to the right. As compared to the right ventricle, the left ventricle is 2 to 3 times thicker. And it has more numerous trabeculae carinae and more finer. And the papillary muscles are larger as compared to the right, and there are only 2 as compared to the right, which is attached to the anterior and to the posterior wall. No septal papillary muscle seen on the left ventricle. The conical cavity of the left ventricle is longer as compared to the right, and the valve that guards the AV orifice is the mitral valve, in which it has 2 leaflets, the anterior and posterior. So as compared to the right, on cut section, the left ventricle is nearly oval or nearly circular as compared to the crescent-shaped right ventricle. So for the septal defects, ASD, or the atrial septal defect, is the congenital anomaly of the interatrial septum. So this one. Usually it is due to incomplete closure of the foramen ovale. With large ASDs, it allows oxygenated blood from the left atrium to be shunted to the right atrium and right ventricle, causing overloading of your pulmonary vascular system. So there will be hypertrophy of the right atrium and right ventricle because the right ventricle is pumping at a right pressure, at a higher pressure because of the resistance of the pulmonary vessels. So for the ventricular septal defects, the membranous part of the interventricular septum develops separately from the muscular part, and it also causes left to right shunting of the heart. Another cardiac malformation is the tetralogy of Fallot. From the name itself, tetralogy meaning there are 4 abnormalities present in the heart. So VSD is one of its components. Then we have overriding of the aorta here. The aorta is enlarged and it appears to arise from both ventricles. And there is also subpulmonic stenosis, this one, and hypertrophy of the right ventricle, because the right ventricle is also pumping at a higher pressure because of the stenotic pulmonary valve. So the patient in this case usually is cyanotic because the poorly oxygenated blood is pumped towards the aorta instead of the stenotic pulmonary valve. So the blood flow towards the lung is restricted under the presence of VSD and overriding of the aorta. So the poorly oxygenated blood is pumped instead to the aorta instead of the pulmonary stenosis. So we have for the valvular heart disease, it can cause either stenosis or insufficiency. And one of the common examples of the insufficient valve is the presence of prolapsed mitral valve. The valve is incompetent, and during contraction or during systole, it will retract back towards the left atrium. So there will be backrush of blood towards the left atrium while the ventricles are contracting, producing murmur. So whenever there is a turbulence of blood flow, it can cause murmur. So in this is the aortic valve. It's either stenotic or insufficient or incompetent. So stenosis means there is failure of the valve to close, to open completely, whereas insufficiency, there is failure of the valve to close fully. So as a medical student, when you're asked about to hear the aortic valve, the sound of the aortic valve, and you're asked to locate the best area of your stethoscope to place in the chest wall. So what will be your answer? Left, right, second, intercostal space. Okay. So for the blood supply of the heart, the coronary arteries arise from the ascending aorta. The right coronary artery arises from the anterior aortic sinus or the right coronary sinus. So it runs along the coronary sulcus. So near its origin, it gives rise to a branch of the sinoatrial area to supply the sinoatrial node. And it also gives off the atrial and ventricular branches. So the right marginal artery supplies the right ventricle, and it also gives off the right posterior interventricular branch to supply the right and left ventricle and the posterior third of your interventricular septum. So the left coronary artery arises from the left posterior aortic sinus or the left coronary artery. So as it enters the coronary sulcus at the superior end of the interventricular groove, it gives off two branches, the anterior interventricular branch and the smaller circumflex branch. This anterior interventricular branch, or known as the left anterior descending artery, it descends down towards the apex or the inferior border of the heart, and it turns around to anastomose, the posterior interventricular branch of the right coronary artery. So aside from that, it also gives off a branch, a diagonal artery, which descends towards the anterior surface of the left heart. The left circumflex artery continues to follow the coronary sulcus towards the posterior surface of the heart. And the left marginal artery, which is a branch of the circumflex artery, supplies the left ventricle. So this is a posterior view of the coronary artery. This is the left posterior ventricular branch and the right posterior interventricular branch, which supplies the posterior, the right and left ventricles posteriorly and the posterior third of your interventricular septum. So please be familiar with the arterial supply of the heart, their course and distribution. So the most common site of coronary artery occlusion is located in the anterior interventricular branch of the left coronary artery or the left anterior descending. So in this angiogram, the occlusion is located in the circumflex artery. So this one. So if the patient presented with a sudden onset of dyspnea and chest tightness, and with these findings of the angiogram, which area of the heart is most likely undergoing changes, or which area of the heart is most likely affected if the left circumflex artery is occluded? The left atrium, left, John. The left circumflex artery is occluded. What will be the area of the heart is most likely affected? The left ventricle and the blood supply. What area of the heart does it supply the left circumflex artery? Anybody? So it supplies the left atrium and the left ventricle. So for the venous drainage of the heart is drained mainly by the veins that empty into the coronary sinus. So which is the main vein of the heart. So this is the coronary sinus. It has several tributaries, the great cardiac vein, the left marginal vein, the left posterior ventricular vein, the oblique vein of the left atrium, and also the veins that drains right side of the heart, the small cardiac vein and the middle cardiac vein. So among these veins, there's only one that doesn't have a valve at this orifice, is the oblique vein of the left atrium. The small cardiac vein and the middle cardiac vein drains into the coronary sinus at its atrial region. And the great cardiac vein drains into the coronary sinus at its origin. Okay, please take note on that. So please be familiar also with the venous drainage of the heart and the nerve supply. So for the great vessels of the heart, this is the superior vena cava, which is 7 centimeter in length. It is formed by the union of the two brachiocephalic veins at the inferior border of the first costal cartilage. So it receives blood towards the heart from the from the tissues above the diaphragm, except for the heart and the lungs. So this superior vena cava doesn't have any lungs. The inferior vena cava, it receives blood from the tissues below the diaphragm, and this is the ascending aorta and the convex part of the arch of the aorta. So it has three branches: the brachiocephalic trunk, or what's the other name? The innominate artery. This is the left coronary artery and the left subclavian artery. Please take note on this. And this is the pulmonary trunk. The pulmonary trunk divides into two, the right and left, and it conveys deoxygenated blood towards the lungs. Thank you.